Drawing machines and other mechanical devices designed to aid in visual art production date back hundreds of years. Artists frequently use the latest technology to communicate their ideas. Harold Cohen in 1968 created what is considered to be the first robot painter, Aaron. From this time, numerous roboticists and artists have worked towards designing robots that can paint, with the most recent being the FRIDA project. Though dragging a brush across a piece of canvas may sound simple, robot painting is not a toy domain. It touches upon all core robotics challenges, making it not only one of the more enjoyable spaces to work in given its aesthetic nature, but a fruitful domain in terms of possibilities to create contributions to general robotics and artificial intelligence research. We will focus on four key robotics challenges that robot painting touches upon. An obvious challenge in robot painting is controlling the brush along with the unpredictability of wet paint. Large precise machines can be used with many different paintbrushes to enable painting at various granularities.
I started painting with robots in the mid 1980s when I was a student at Carnegie Mellon, and I became interested in an essay by Walter Benjamin where he talked about art in the age of mechanical reproduction. He was talking about photography and how that changed art because it allowed anyone to make photorealistic images, and that allowed artists to move in new directions, in particular into conceptual art. And in my case, I was interested in how the robot would create images with brushes that were essentially imprecise, and how that reflected the inherent imprecision of real robots. As I knew, it was extremely difficult to get robots to do things precisely. And so I really like this idea of these paintings that would illustrate that in a very visceral way.
With the controls of the robot in place, the robot now needs to plan the brushstrokes. In a computer simulation, the robot can plan future brushstrokes, but closing the gap between the simulation and reality is notoriously challenging. Some works model brushstrokes with graphical models, such as Voronoi. These models are altered and tuned to match the real world as closely as possible. Others try to model the strokes with black box learning algorithms, training on small sets of real world brushstrokes. While many robot painters plan from just image inputs, some works plan from more abstract interactions, such as natural language.
Making robots to perform the tasks that we want to accomplish requires the robots to have a semantic robot intelligence that integrates computer vision, language understanding, and planning, whether it's navigation instruction following or making arts.
Once the robot can plan in simulation, it now needs to figure out what to draw. Harold Cohen created perhaps the first machine to be considered a robot painter. He wrote rules to describe how objects should be represented on a two-dimensional surface using a pen and colored with paint. Subsequent work focused on reproducing photographs and computer images using robots, akin to a stylized printer, or plotting geometric patterns and vector art. More recent works harness the recent developments in large probabilistic models to paint from given speech inputs and text inputs. Some even extend towards sound and emotional guidance for generating paintings. Art is something that people create, though, not robots. It's a means of communication, cultural values, and shared understanding. Therefore, a robot painter must satisfy a human user's artistic vision in order for the product to be considered art. The ultimate challenge of robot painting is supporting human artistry, relating to the robotics field of human robot interaction.
It's simultaneously frustrating and inspiring translating artists' motions onto a robot platform because robots just don't move the same way we do. Sometimes we invent not only new algorithms, but also new artistic techniques to bridge that gap between human expectations and robot capabilities. For example, we faced a lot of challenges spray painting graffiti because the artist would always want these crazy fast direction changes that the robot just couldn't keep up with. In the end, we did make upgrades to the robot, but the artist actually also found inspiration in those unique imperfections of the robot's execution.
Many robot painting projects focus their contributions on one or so areas of robotics, but they all must tackle each challenge in order to successfully put paint onto canvas. To create a robot that is extremely successful at robot painting would be a robot that is successful at all core robotics challenges. So, when developing artistic robotics, don't think about it as robots contributing to art, think about it as art contributing to robotics. Art, like math, allows us to formulate complex technical problems in the purest way.